This is Unit 5, Periodic Table. Lesson 1, Development of the Periodic Table. How has the organization of the periodic table changed over time? You should be able to explain how the periodic table was developed and organized, and you should be able to identify similarities and differences between periods and groups. So, do now review from our last unit. So Mendeleev was the first scientist to organize the elements, and he did so based on their atomic mass. Um, at the time, that was the best information they had, so he organized it, and this was his original publication of the periodic table. So maybe if you're interested, you can look at that sometime. Most of the elements fell into a similar organization as they do now. However, as we learned over time, organizing by the atomic mass was not completely accurate. Therefore, Moseley developed the modern day periodic table where he organized them based on the number of protons, or aka their atomic number. And this was a more accurate representation of the periodicity of the periodic table of the elements. And that leads us into our periodic law. This is when we have similar properties occurring periodically when elements are arranged according to increasing atomic number. This is similar to the calendar. Every year we have the same dates occur around the same time. So as fall approaches and the leaves start falling off the trees, that's about the same time in October. That means we have the same types of things recurring periodically. So the result was Moseley was able to predict undiscovered elements and their properties. So these little dark squares here, those were elements that did not exist or were not discovered yet at the time of the development of this early periodic table. So how is the table organized? The periods are the horizontal rows, and this is equal to the number of energy levels or shells that each atom has. The groups are the vertical columns, and these are the elements have this, and in groups, elements have the same number of valence electrons, which results in similar chemical properties. So that's a very important um, fact. The number of periods tells us the number of electron shells, otherwise known as the principal energy levels. The properties of elements can change drastically across a period. So as we go from left to right, the metallic properties decrease. So we start with metals to the far left, and we cross our semi-metals, and then go over into our non-metals as we go across horizontally. The valence number of electrons increases from left to right. So this is left to right. From one valence electron in the far left all the way up to 8 valence electrons in the far right. And each of the group numbers tells you the valence electrons. So there are 1, 2 valence electrons. Our transition elements have variable valence electrons, and that's due to their unique properties. Then 13, 14, 15, 16, 17, 18 are the group numbers here, and those last numbers tell you the number of valence electrons. The reactivity of the elements is determined by the number of valence electrons. All atoms except hydrogen wishes to get to 2, doesn't wish. Hydrogen is stable with 2 electrons. All others are stable when they have 8 electrons. And that's an importance. This is called our stable octet. So the closer to a stable octet, the more reactive that element is. So for example, if I have just one extra electron, I'll be very reactive. If I need one more electron to reach my stable octet, I'll be very reactive. The exception is in period 1 elements, hydrogen and helium. They only need 2 to have a full shell, not 8. So, for example, which 2 elements have similar chemical properties and why? So we need to look at our periodic table, and we're going to find the 2 elements that are in the same group. So when you look, you'll see that sodium and potassium are both in group 1. They have similar chemical properties because they have the same number of valence electrons, and therefore they are in the same group. All right, so check your understanding. So at the end of this lesson, you can now explain how the periodic table was developed and organized, and you can also identify similarities and differences between periods and groups.